Hello, everyone. You are welcome once again to the lesson on indices and logarithm. And today's lesson is going to be lesson number 3. Okay, and we are going to continue from where we left off in lesson number 2. In lesson number 2, we're looking at how to solve exponential or indicial equations. So we had quite a number of them, okay, solved. And in today's meeting, we are equally going to continue. However, we'll be looking at this time round exponential equations that will lead to simultaneous equation. Remember in lesson 2, all the equations that we solved, okay, we dealt with only one variable. But just as you can see before you, okay, in the 4 equations that you are asked to find the solution set, okay, in each pair, okay, you see 2 unknowns. The first one, you see x and y. The second one, which is the b, you see m and n. Okay, the c, you see x and y again. Then the d, you see, okay, a and b. So obviously, you know, when you have 2 unknowns, then it means we have to generate 2 equations before we can find the 2 unknowns. So please stay glued to your seat, give me your maximum attention, and let's look at how best to present the solution to questions of this sort. Okay, and once again, okay, I plead, if there is anything that you don't understand at any particular point, please don't hesitate to let me know. I am here because of you. Okay, so let's go. Okay, so question number 4, we are supposed to find the solution set of the following. So as you read question, you can see that solution set is very critical for us to underline. So we have underlined solution set. Okay, meaning if our final answer is not left in the solution set form, okay, we will not get the final answer, okay, mark. So quickly, let's go and have the solution to that of the A. Okay, so you are finding the solution set. Okay, if we're asked to solve, then you know, ordinarily we solve equations, but when we attach other vital information, you underline the vital information, which I said solution set is vital. So it has been underlined. Okay, now let's see. Okay, if you look at this, in any question I've told you, where you are given more than an equation, okay, immediately you write the first equation, label it. Okay, you write the second equation, equally label it. Because obviously we can see 2 equations here. The first equation and the second equation. Do we agree? Okay, so now solution. The question has a major question number, which is 4. So you write that. And a minor question number, which is A. So you write that as well. Now we are going to extract. So you can write given or you can ignore the given. Okay, so now the first one, I'm going to write the given. So what are we giving? We are giving, okay, the first equation is 2 to the power x plus y. That is equal to what? 8. I will call this equation 1. Okay, if you have space, you can come and continue, or write comma, or write end, then extract the second one too and label it. But I don't have space, so I will come down and write end. Okay, my second equation is what? 2x plus what? Y is equal to 4. And I label this as what? Equation 2. Is that clear? Okay, very good. Okay, so now this is what we have. Okay, 2 equations with 2 unknowns. However, if you look at the first equation, you can see that the equation is not that pretty, meaning it's not in the form that we usually solve equation. Whenever we are solving equations, okay, simultaneously, you realize that the 2 equations that we will solve, or the equation that we will solve simultaneously, okay, whether 2 or 3, okay, take note, they are supposed to be in the normal form. Okay, not the exponential, not any other form. So the second equation is in the normal form. Can you see? The usual form of equation that we solve. However, the first one is not. So it means the first one, we have to work on it. Okay, move it to our comfort zone, which is take it to this form as well. And we know how to do that based on what we did in our last meeting. So this is what we are going to do. So from the first exponential equation, so this one, the question gave you an exponential equation and ordinary equation, and we are asked to find the unknown. So come and write from 1. We are going to work on equation 1. So from equation 1 circled. And I've told you don't write equation 1 this way. Just write 1 circled. I'm repeating that because I know some of you, okay, your ears are hard. All right, okay, so let's see. This is what we have. So we are going to, okay, write this one, express this one in terms of what? This form. So now what do we do? This side has, okay, 2 to the power x plus 1. S plus y is equal to, you also write this as a common base, 2. So you are going to get your base 2, okay, to be common. Then now cube, am I right?
Yes.
Okay, so now what do? We can equate the exponent, is that not it? So if you equate the exponent, we are going to get x plus y is equal to what? 3. So you can see that this is now of this form. So what do? We label this. Someone can label this as equation 3. But remember, I've told you that anytime I take one equation and work on it, I'll write the name of the main equation, then attach a sub to it. So a letter to it. So 1a. Meaning this is a baby of what? Equation 1. I took equation 1 and worked on it. So in a situation where there are issues, if I want to trace the parents, okay, equations, it will be very easy for me to trace and do the correction thereof. Okay, so now we are going to solve these two equations simultaneously. Equation 2 and equation 1a. And remember, I've told you anytime you are solving equations simultaneously, because you are at liberty to, okay, use any of the methods, listen to the equations. Always one of the methods will be ideal. The equations will tell you the ideal method to deal with or to use. So in this case, having listened to the equations, I can see that the equation is telling me, or the equations are telling me, I have same coefficient for y. Okay, 1, 1. So I can easily eliminate what? Y. So I will go for the elimination method. Is my point well made?
Yes, please.
Okay, so that doesn't mean you cannot use the other method. You can, only that it will be ideal for us to use this method, okay, which is the elimination. So if I want to eliminate, I want to avoid negative as well. So if I know that y will go, the x here, so it means I'm solving for x. In the 2 equation, the bigger x here is this, is in the equation 2. Can you see? This is 2x and this is x.
Yes.
And because the signs are the same, I'm going to subtract to eliminate. So I have to consider this, okay, 2x, which is the bigger one, and this one. So I'll subtract this second equation from the first equation here. So 1a, okay, from what? The equation 2. So I'll write, okay, equation 2 minus equation 1a. And like I always say, there will always be space here. Okay, so don't leave this line, okay, just with occupied by just this short, okay, expression or whatever that you've written here. Write command and come and do your subtraction there. So you get 2x minus x, and that will give us x is equal to y minus y. That will give you 0. That was your intention. So purpose achieved. Y has been eliminated. Hello, Sadem.
Sir, please. So we can do it directly without showing how we did it. Like
As in,
x minus, like you write 2x and then minus x,
oh
then
no,
write
you can. I've told you, anytime you are combining, anytime you are subtracting, anytime you are adding, whether you are adding variables or you are adding constants, you can always do that, okay, mentally.
okay, sir.
Or you are adding or subtracting. So there is no need to, okay, show. If there is a need, I will tell you. Remember, your marks are mine as well. All right. Okay, so I won't teach you anything that will make you lose marks. Okay, or that will make us lose marks. So now, please, you should all unmute. All right. So what do we have? We have x. Now the y will go. Okay, Karen,
My was back. I left the class and joined
come again.
again. I don't understand the phone.
You don't understand what?
My connection.
Your connection was bad. And I've told you if it's an issue with connection, okay, please hold on. Okay, and let's continue. Try to relate. This is the first example anyway. At least you'll be able to pick something from here. In the subsequent examples, maybe you pick the rest and you are good to go. Because your
So I
network is
left
still
the
not helping you.
class. So I
And I,
just joined.
and I'm
So
saying that because you still have the problem with your network, even if I go back, I'll have to keep on going back. So you wait, try to follow once you have rejoined. Okay, if you're unable to follow, there is another question on the way. Okay, maybe by then your network will be fine. Then we can continue from there. Is that clear? Otherwise, then it means you have to wait for the video and watch. But I'll still factor you in when I move on to the next question. So please don't worry at all. You will get it. All right. Okay. So sorry for the unstable network. So you have x to be equal to here. The y will go. So it will be 4 minus 3. That is 1. Is that clear?
Yes.
Okay. So you label this as equation what? Equation 3. Okay, now you write equation 3 into, and I've told you don't write puts, don't write putting, don't write substitute, don't write substituting. Just write this. It still establishes that point. So equation, okay, 3 into which one? Which one will you go for? Which of these two equations, okay, will be pretty? I think
Two.
in 2. Okay, so no, equation 1a. 1 is prettier. 1a is prettier. So take note. Okay, all right. So now what do? We are going to, but I can equally advise that it will be better if you substitute it into this one. This one was not generated by you. It came from the question. This one was generated by you, so it could be wrong. You get it? But we are sure this is right, so we are going to substitute here. Because if you substitute, the work will be very easy. Making what? Y the subject. So it will be into 1a. If you want to substitute that into 2, you can. Then comma. Okay, so we are going to get wherever we see x in 1a, it is 1. So you get 1 plus y is equal to 3. Is that clear? So it means our y will be equal to 3 minus 1, which will give us what? 2. All correct.
Yes, please.
Okay, so I'm going to have my conclusion drawn. So I'm going to have maybe therefore, okay, x is equal to 1 and y is equal to 2. Okay, should that be my conclusion?
no,
No.
No, remember we are finding the solution set. It's the same as the true set. So your final answer must be in the set form. So you draw your conclusion. Therefore, you know when you have only one, okay, variable, usually you conclude by saying x is such that s is equal to that variable, you state its value. Now, when you have two variables, this is how you conclude. It will be x, okay, assuming your variables are x and y. So it will be x, comma, y is such that, then you come and write s is equal to its value, comma, then y is equal to its value. Or you can write and y is equal to its value. So that's exactly what I'm going to do here. So it will be therefore, okay, x, comma, y is such that, okay, so it means x and y will be such that x will be equal to, I had s to be 1, okay, and you can write and or comma. Comma also will mean and, okay, and what y is equal to what 2. It's my point well made.
Yes,
Hello, it's my point
please.
well made. Okay, Blaze.
Mr. Hoffman.
Yes, please.
Please, you first said that the equation y for the y it will eliminate the y in equation. So why is it that now y is 2? So I said it becomes 0.
Oh, you eliminate y or you eliminated y. Okay, here, that's why in this equation, do you see y?
No.
So it means what you were doing here, you were eliminating y to find x. So you eliminated y to find x. Now you know x. So you use the s to come and find the value of y.
Okay.
You get it? Not that you are eliminating y, so y will go forever. You eliminated y
Yes,
because
please.
you wanted to solve for x. Okay, know the x value. So after finding the x value, you use the x value to predict the y value. Is that clear?
Good.
Okay, very good. Any other questions? Okay, Matilda, are you able to follow? Were you the one who said
Yes,
your
please.
network was giving you issues?
Please.
Okay, you are able to follow, right?
Mr. Hartman.
Mr. Akman, please, it wasn't me.
It was who? Please, who had network issues and was not able to connect from the beginning in terms of understanding?
It was Karen.
Okay, Karen, yeah, Karen, are you fine now? Is it better?
Yes.
Okay, so I
I
told
just
you.
have one.
Okay, ask.
Is it the naming of the equation? You named it 1A.
Mm-hmm.
Why didn't you just equation 3 or equation?
Okay. All right. Okay. So I explained that anyway. Maybe because of your network, you didn't get it. Someone is redesigning mine. So I've disabled the annotations. Okay. So now this is it. Okay. Remember I said, okay, anytime you take one equation and work on it to get another equation, I usually want to keep the main equation number and attach something to it. Just for me to know that I worked on one equation so that this will be a baby of one. So in case I have any issues with my answers, I can trace if there are issues because I will know the parents and the babies.
Okay, thank
Uh, You understand now, all right. And when you work on two equations, that's when you give it a different and entirely different number. But that doesn't mean you cannot call this one. That doesn't mean you cannot call this one equation 3. You can. You can label it anyhow. Only that I find it convenient because of that simple reason that I just gave. So please, if you don't have the floor, make sure your audio is on mute. You know this basic rule. Okay, for our Zoom meeting. All right, any other question? This is the first example. Okay, so please ask questions. Do ask questions if you have. All right, so we thank God we are all fine with this. So let's move on to the second one. Okay, so B is what we have there. Please. Okay, so now we have the B. We are equally finding the solution was set. So as usual, what do you do? Okay, we are looking at 4B. Solution is what you write for, but because it's the same major question, when you write the solution, you write it once. Okay, so you don't write the solution, okay, sub question wise. So this will give us 4B. Blaze.
Sorry for interrupting, but say the previous question.
Mm-hmm.
Are you supposed to subtract the small variable from the big one?
Okay, so I
So that
said you can do your subtraction anyway. Once you have your two equations, okay, it doesn't really matter whether you do equation 1 or equation 2. However, like I always say, think before you write. If you do that, you sometimes write less and save time. So here, because we were looking for x, and we realized that we were supposed to work on equation 2 and equation 1a. We could have done equation 1a minus equation 2. In that case, when you subtract, it will be x minus 2x, which will give you minus x. Is that not it?
yeah, yes,
Okay, in
please.
that case, once the coefficient of x is negative, when you are finding x, you have to divide by negative. So that will be more a step. You get it?
Yeah,
But if you
yeah,
do the other way around, when we subtracted, you saw that we had the x value straight away.
yes.
So usually, and I usually do that because I want to avoid working with negatives. And I've told you that
Okay,
if I can deal with the negative from the initial stages, I will do so before it gives me trouble in the short or long run.
yes.
Okay, all
Um,
right. So that informed that decision for this subtraction. However, you could have done 1a minus 2 as well. So can I move on? Go.
yes, please.
All right. I like it when you ask questions, no matter how trivial the question is, I will answer. Okay, so that's your problem. So I have to deal with it anyway. All right. So now what do we have? With this one, we have two equations, so we are going to extract. Okay, so I won't write the given. I've told you can choose not to. So I'm going to write 2m plus 4n, okay, is equal to 1. I will label this as equation 1. Okay, and, or I can write comma. I've told you comma can also mean and in math. So 2, okay, m, or 2 to the power m, forgive me, okay, plus 8n. So the power is m plus 8n is equal to 1 over 4. Okay, now I'll label this as equation 2. Is that clear?
Yes, please.
Okay, so if you remember the first equation, you had one equation which was in the friendly form, the usual form, but the other one was not. However, this time around, both equations are not that friendly. We cannot work with them directly. Is that clear?
Yes, please.
Because they are all exponential. Okay, and you don't directly solve two equations simultaneously exponentially. So what do? You are going to move each one to your usual form. So take the question home. Okay, so now what do we have? You come and write, you have to work on this. So you come and write from, so let us know which equation you are working on. So from equation 1, comma. Okay, we are going to work on this. So we know that this is the same as 2 to the power m plus what? 4n is equal to, remember we said anytime you see 1, is the same as your base here to the power 0. Do you remember?
Yes.
Yes.
Okay, so this will imply that we are going to get, now the bases are the same, so you equate the exponents. M plus 4n, okay, will be equal to 0. Okay, you can see that we took 1 and worked on it. So what will be the appropriate name based on the advice?
1A.
1a. So it means if you come and take 1a and work on it, you call it what? 1b. Is that clear? If you like. Okay, or you take equation 1 again and you work on. So 1a, that's what we have. So you have this equation, the original equation, which was not that friendly, or not the form that we usually solve equations simultaneously, okay, using. Now it's of this form, your usual form. So you are through with this. Come and take this one too. So let us know. Okay, so now from equation 2, comma, we are going to get 2 to the power m plus what? 8n. Okay, will be equal to, and we know that this is the same as 1 over 2 squared. Is my point well made? Okay, so we are changing this one to the usual form. Exponential equations, simple ones, we are masters now. So this implies that my 2 to the power m plus what? 8n will be equal to 2 to the power negative 2. Do you agree? Hello, are you all with me?
Yes.
Yes,
Okay,
please.
so now the bases are the same. So, and single base to a power single base, so we can equate the exponents. So we are going to get 8, m plus, okay, let me move in that direction. Forgive me, let me clear that. Okay, so at this point, what do we have? We have, okay, m plus 8n is equal to minus 2. This equation you can't reduce. It's already reduced. The coefficient of m positive, you always want to. So in this case, you call this one also 2a. Is that clear? So now, which equations are we going to work on simultaneously?
1A
Equation
and
2.
2A and 2A.
1a and 2a. So let's listen to these two equations. Okay, the coefficients, we want to see whether elimination, if elimination works, that's the best method. So here, coefficient, I've told you for elimination to easily work, the coefficient of whatever you want to eliminate should either be plus or minus the same value. So here, this is plus 1, okay, so the same. So I can easily eliminate m. Let me go to n. 4, 8, no. So I can eliminate n, but not easily as what? M. Is that clear? So I will go and eliminate m. Is my point well made?
Yes.
Okay, and the first equation, the 1a and the 2a, they have the same sign, plus 1 plus 1. So when you are eliminating and you have the same sign, you subtract. If you have opposite sign, you add. So here we are going to subtract. And again, let's see. Okay, Blaze, based on this question, I'm directing it to you because you asked, okay, that question, why I did that subtraction that way. So based on the advice, Blaze, are you supposed to do 1a minus 2a or 2a minus 1a?
So please 2a minus 1a.
Okay, why?
This is because when you subtract the 4n minus the 8 and you get a positive value and you don't
Perfect.
want to do
That's it. Perfect. You are some here. Okay, so as simple as that. Okay, you want to avoid negative, basically. Okay, so once you agree that that's what we are going to, then this time around, we'll do 2a minus what? 1a. Okay, so comma. Then this time around, look at the way you are going to move. It will be this minus that, so be very careful. This minus that, so all of them, it will be the down minus the up because of your statement here. So m minus m will go. That's your intention. So you don't write 0 there. It is gone. It's simply understood to be there. Then 8n minus 4n, and that will give us 4n. All correct? And that must be equal to negative 2 minus 0. So that should give us negative 2. Am I right? So you come and write it again before you divide. And please take notes. Okay, in the elective math assignment, most of you didn't do this. Or I should say some of you, if I'm not exaggerating. Okay, so over what? Over 4. Over what? Over 4. So it means my n will be equal to minus 1 over 2. All correct?
Yes, please.
Okay, and you will need your n to find your m. So we are going to label this as equation 3. Okay, so 3 into, and I've told you don't write puts. Into which of the two equations will you substitute? Do you think it will be easy for you to work on? I think equation 1a. Okay, so I'll substitute that one into equation 1a. My professors, I hope you are following.
Yes, please.
Okay, so comma. So that will give me m, okay, plus 4 into your n. And n is what? Minus 1 over 2. Okay, and that is equal to what? 0. So here we are going to get m. Okay, the power here is 1, so you can cancel. If it's any other power apart from 1, then you have to push the power in before you cancel. Remember yesterday what I told you. So this will go here too. So it will be 2 times negative 1, which will give us negative 2, and it's equal to 0. So I will get my m to be equal to 2 here. All correct?
Yes.
Okay, so now we know the values of what? The m and n. But so we need to draw our conclusion, but our conclusion must be in the true set form. Remember, so you write therefore your m. Okay, sorry, my m comma n is such that my curly bracket m is equal to 2 comma n is equal to what? Minus 1 over 2. Then you close it. All correct?
Yes, please.
Okay. Please, is everyone fine? Okay, very good. We thank God. All right. Okay, so please do ask your question.
Sir, please, when you are putting the n into the equation, I want to ask, why didn't you choose equation 2, but you chose equation 1?
Okay. You asked for
1a, sorry.
we meant okay. I said you can put it in any of them. Only that always go for the equation that usually I would say the smaller equation. Smaller equation in the sense that the coefficient involves smaller numbers.
Okay.
Okay, but any of them will do.
Okay.
All right. Okay. All right.
Thank you, sir.
You are welcome. And you can see that if you substitute it here, okay, there will be more work because of this.
Okay.
And after that, when you move, okay, so
Okay.
that's it. Are we all fine now? Okay, great. So we can move on to the next one, right? Okay, so I am going to do just that. Okay, so the last one for all of us. Okay, then after that, the D will be yours. Okay, all right. So quickly, let's go and look at that of the C, the solution. So we are more than good to go. So C, 4C. Okay, again, what are we giving? We are giving 3 to the power x, okay, times 3 to the power y, okay, is equal to 2, 4, okay, 3. I will call this my equation 1. And we have, so let me put the end here, or you can choose not to write the end or comma. Okay, so and we have 3, okay, to the power x, divided by, this time round, not times, 3 to the power 2y is equal to what? 9. So you call this equation 2. All correct?
Yes, please.
Okay, all right. So now you know that these two equations, each of them is in the exponential form. However, we can't solve exponential equation directly simultaneously. So we have to take it to our comfort zone. Okay, all right. So at this point, we know we are going to write this, okay, in the usual exponential equation, how we solve if we are dealing with only one variable. So what do? You come and take from 1, okay, from equation 1. Okay, we are going to get what? You know, the bases are the same here. We have to write this to be a single base, but we have 2 bases here. So you keep the common base 3. And because they are multiplying, you add the exponent. So that will give you s plus y. All correct? Okay, and that should be equal to 243 yesterday. We realized that that's the same as 3 to what power?
5.
5. Okay.
5.
All right, so at this point, single base to a power, single base to a power on each side. So we just equate the powers. So we are going to get x plus y is equal to 5 to be one of our main equations. So I'll call it 1a, forgive me. Okay, then we come to please mute. All right, please mute if you know the noise is coming from your end. Okay, or you've not muted. So now you go to equation 2. Please, my professors, are you following? Okay, very good. So from equation 2, okay, this one, this side has more than 2, okay, bases. Okay, however, you can see that you are dividing. So the 3 to the power x divided by 3 to the power 2y, it will give us that common base 3. Then because you are dividing, you subtract the denominator power, which will be this, from the numerator power. So that will give us x, okay, minus what? 2y. Is my point well made? And that should be equal to 9 is the same as 3 squared. So again, the bases are the same, okay, and we are going to equate the exponents. So this implies that my exponent x minus 2y should be equal to the exponent here, which is what? 2. So equally, this equation I can't reduce, I can't do anything. It doesn't contain brackets, it doesn't contain fraction. So I can label this, and this will be my equation 2a. All correct? Okay, very good. So now we are comfortably going to solve equation 1a and 2a, okay, simultaneously. So if you listen carefully, you realize that we can easily, once again, eliminate x. Plus 1 plus 1. So same sign. So we subtract to eliminate. Okay, so with this one, let's see. Okay, what is going to inform our direction of subtraction? Okay, so let's see. If you do equation 1a minus equation 2a, you get y minus 2y, which will give us a positive 3y. Am I right?
Yes, please.
However, if you do the other way around, you are going to get minus 2y minus y, which will give you minus 3y. And here is the case we said we want to avoid negative. You get it? So, however, if you like negative, I don't like negative. But if you like negative, then go that direction. Is that clear? Okay, so now what do? We know the direction to go, the right direction. So it will be equation 2a rather, okay, from what? 1a. So it will be 1a minus 2a. Am I right? Okay, and that will give us x minus x. The s will go. Oh, so it is rather, oh, sorry, I'm doing minus 2a, so it will be x minus x this way. So I'm subtracting this one from that. So x minus x, the s will go. Y minus minus 2y, so that will give me 3y. And it's equal to, I'm going to get 5 minus 2, and that will give me 3. All correct?
Yes, please.
Okay, so remember, you don't divide straight away. So those of you who have been doing that, again, I'm cautioning you. So you write it again before you divide. Over 3, okay, over 3. Okay, so y will be equal to 1 here. You need y to find what? Your x. So you call this equation 3. So equation 3 into, okay, which of these two equations will you go for?
1A.
1a will be better, because if you substitute, okay, the y that you are looking for, you don't have to move it. It will still be here, and you move the other, so into 1a. However, any of them will go. Okay, so comma, you have x, so, oh, we are looking for x instead. So the x, you will not move it. It will still be here. So you get what? X plus what? Plus 1, which is your y, is equal to 5. So it means my x will be equal to 5 minus 1, which will give me 4. Okay, so I know my x and what? Y. I can comfortably have my conclusion drawn now. Therefore, remember, we are dealing with sets. Okay, so x comma y is such that x is equal to 4 comma y is equal to what? Is equal to 1. All correct? Okay. All right, so I'll give you some time to write, then we'll come to the last question. If you don't have any question, okay, give me some few seconds. Okay. Okay, so that will be it for the solution to the C. Okay, so let's move on to that of the D. Okay, D is this, and unfortunately we can't do the D because I picked this question as what? Your assignment. Okay, so we are going to look at the last set of what questions. Okay, this set of questions quite different from what we've done so far. However, before we come to this, you know, okay, we've done, okay, our 1 hour. Let's go and have our water break. Is that clear? All right, okay, so like I was saying, anyway, welcome back from the water break. Okay, so we have our last set of questions before, okay, us. Okay, and this question, in fact, we are not dealing with what? Exponential equations. Okay, you see this form, which is in the exponential equation form. However, for you to solve here, you have two unknowns or two constants, x and what? And k. For you to solve for the x, this must be a specific value. Okay, so that you can write this one as a base, okay, which is the same as this to a certain power, if possible. If it's not possible, that's when I said you bring in log. But with this one, because its value was not given, that's the more reason why, okay, the question is put in this form. Express the following in terms of k. So you are going to express the following exponential, okay, expressions that we have here, also in terms of what? K. If you are told that 2 to the power s is equal to k. Okay, on the face of it, it might look difficult, but it is not. Okay, so let's look at how to deal with this question. In fact, let me see if I can convince you, okay, and you agree with me that it is not difficult. Okay, so quickly, let's move on to our next slide, which happens to be the solution slide. Okay, so now, okay, as usual, when you read question, okay, we are supposed to express the following in terms of k. So if your answer is in any other letter apart from k, the only letter that you should see in your answer should be k. So in terms of k, let me underline the whole of in terms of k. So that's the salient part. Okay, so now let's set the ball rolling. 5. So solution to question, our major number, question number is 5. Okay, and 5, you can see that with this 5, there is an information provided there, and that is a general information that you are supposed to use for the whole of this. So I'm going to extract that one, okay, that information also. I won't do it as A, then I extract. Okay, it's a general information, so I'll extract that general information, the question attached to that number. The question number is 5, so I'm going to get given, okay, 2 to the power x is equal to k. Okay, now you come to A. Okay, A, what are we given? We've been given 2 to the power x, 2 to the power x plus 1. Okay, however, there's an expression. This will be equal to, so let's see. You know, in indices, anytime you have your exponents, okay, the terms adding, then it means what were you dealing with? Any ideas?
Multiplication.
You are dealing with multiplication. So it means you had, okay, 2 to this power x times 2 to this power 1. And you wrote it as a single base to this power. You get it? So we are going to go back from where this came from. Is that clear?
Yes,
Please, are you with me, my
Yes.
professors? Are you with me?
Yes,
Yes,
please.
So we know that this came from 2 to the power x times what? 2 to the power 1. Is that clear? But you can choose not to write what? The 1. Okay, and anytime you have a constant and a variable, usually you write the constant first. However, I will carry out my substitution. So I can say that this is equal to, so let me write the constant first. Can I write this as 2 times what? Okay, let me put it this way. 2 times 2 to the power x. Do you agree? Is the same. So can I say that this will be equal to 2 times, what is your 2 to the power s? You are told that 2 to the power s is k. Can you see that?
yes.
Okay, so I did that substitution. Wherever I see 2 to the power s is k. So I'm going to write therefore, okay, 2 to the power x plus 1 is equal to 2k. So I've been able to write this one also in terms of k. All correct?
Yes, please.
Okay, please, are we all fine? Any questions? This is the first example, so if you don't understand, please let me know. Yes?
Thank you.
So to solve this kind of question, you have to get what has been given at the beginning, then you substitute it.
Yes, you have to get it in your, okay, results or in your transformation or your transformed relation or expression. You have to get it there before you substitute. Always.
So you reverse the whole thing.
Come again.
It's like you are reversing.
Yes, you are reversing the whole thing. Okay, so it means if you are giving any, you are using the laws, okay, in the reverse manner, basically. Okay, all right. So if that is if the point is well made, then let's look at B. B, what are we giving? We are giving 2 to the power x minus 1. So anytime you have what? Remember, anytime you have your exponents, okay, the terms you are subtracting, what does that mean? Division. So it means initially you had 2 to the power x divided by 2 to the power 1. Am I right? Is that clear? Okay, however, we know that 2 to the power s, we're told that it is what? K. I hope you are with me. So my numerator will be k and my denominator will be 2. So in that case, I'll say therefore 2 to the power x minus 1 will be equal to k over 2 or half k. Please, I hope you are following my professors.
yes, please.
Okay, very good. So 2 gone,
Yes.
3 more to go together. Okay, then the F obviously will be yours. Okay, so now let's look at that of what? The C. Okay, C, what are we giving? We are giving 2 to the power x, okay, minus 2. So likewise, because you see minus, it will be 2 to the power x over minus is over, then 2 squared. All correct. Adoma? Aduma, your hand is up. Please unmute, then respond. Okay, unfortunately, we can't hear you. I don't know whether you are talking. Okay, so Aduma, please unmute and respond.
Yes, sir.
Uh-huh.
Yes, I think it's Karen.
Come again.
This is Karen.
Okay, Karen. Okay.
Please, the line was breaking, so I didn't hear what you said clearly when you were explaining the second step in B.
The second.
Step in B.
Okay, the second step, which is this one. This is the second step. No, this is the first step. This one is just extraction. Your steps are where you have your equal to's. Is that clear? So get the language right so that will be. Okay, so we said because this one, anytime you see addition is coming from multiplication. It means you had what? Bases to be the same and the exponents you added. Okay, if it's subtraction, then it's division. So that's what we did. So this came from, okay, so if I have a to the power m minus n, that came from a to the power m over a to the power n. Is that not it?
Okay.
So that's what I use here. Okay, another question.
Can you write it in like a linear form instead of this?
Can you write it?
In the form 2x divided by 2 raised to the power, like using the sign instead of the bar.
Yeah, you can use that. Okay, you can use that. It's allowed. Okay, you can use that. Okay, only that is usually convenient for us to, because if you use the division, your conclusion, you will still have to change this one to the bar because you can't write k divided by 2 as your answer. You get it?
Okay.
All right, so you have to start with the division bar instead of the division symbol. So in the same way, this will be equal to quickly. Okay, so k, okay, I know that this will give me 2 to the power x over what? Over 4. Is that not it? Do you agree? Okay, so this will be equal to 2 to the power x, we know is k, over, okay, 4. So now, therefore, I can write 2 to the power x minus 2 is equal to 4. All correct. Okay, sorry, it's equal to k over 4. All correct. Okay,
Yes,
very,
sir.
very good. Okay, so on this note, okay, try the D and let me see. Okay, we'll come and look at it together. Give me some few seconds. Once again, I'll be with you. So, Aduma, yes.
B. Can you write it as K2 to the power negative 1? Or
K,
is that necessary?
K2 to the power negative 1.
Yes, please.
I almost said I won't mind you. Remember, I told you that you don't conclude with a negative exponent, true or false?
True.
So that answers your question. Is that clear?
Yes, please.
Okay, so avoid negative exponent conclusion unless otherwise stated. Great. All right. Okay, so now let's move on to the D and the E. 2 more to go. All right. So D. Okay. D, what do we have? We've been given 2 to the power 2x. So 2 to the power 2x, what is the meaning of this exponent here? It's 2 times x, right? Okay,
Yes,
so
please.
whenever you multiply, okay, you have 2 factors in your exponent. Okay, you know it is coming from the power rule. Is that clear? Okay, and the
Yes.
power rule, you have 2 ways. It's possible this is coming from 2 squared, okay, all to the power x, or it's coming from 2 to the power x all squared. Do you agree? You know all of them, this will give us 2 to the power 2x. Do you agree? This will also give us 2 to the power 2x. So it means this will have 2 ways, okay, in expressing it. Is that clear? Should I come again or my point is well made? Is my point well made?
Yes,
Yes.
please.
Okay, very good. However, because of what we want to do, what we want, the form, we want 2 to the power x. Okay, so the power of the x, okay, the power of the 2 should be x, not what 2. So it means this is the right direction to go. You get it?
Yes.
Okay, so in effect, I'm going to write this one as, okay, 2 to the power x, okay, all squared. Is that clear? However, we know that 2 to the power x, we were told is what?
K.
K. So we are
K.
going to k, we'll get k, then was squared. Is that clear?
Yes.
Okay, so we end up getting therefore, okay, 2 to the power 2x. In terms of k, will be what? K, okay, squared, small k squared. Afa.
Yes.
Okay, very good. All right. Okay, so I think we are more than good to go now.
Teacher, how can
Yes, please.
teacher, how can he?
Come
I
again.
solved this question. I solved it differently and I got a different answer.
You got okay. So tell us what you wrote and let me see whether there are flaws in what you wrote. Then I will fine tune that.
You see, you said that it's either that it's 2 squared, then x is outside it.
Mm-hmm.
And like 2 squared is, we can use a square
Okay, so
times.
4. No, 2 squared is 4.
No, I use
No,
a
you use square.
square
You let me allow you
outside.
to talk. You use square root where?
I square rooted the whole 2 raised to the power 3x. Then I
So
put it as outside and
you wrote
well,
this way:
1 over
root of
2.
what? 2. Okay, squared. Am I right? Is that what you wrote?
Yeah,
Then your
yeah.
where was the x? Or where did the
The
x go?
x
The
was
x.
still high.
Okay, so this is there.
Yes,
Okay, now
yes,
let's see. You hold on. So it means you came from here. You wrote 2 squared. You wrote this one, right?
I just went straight away to do the second step.
No, so no, I don't know whether you wrote. So which one? Where did you start? I want to know where you started.
The second step.
Okay, you started from here.
Yes,
So meaning from 2 squared, okay, x, so 2 to the power 2x, you came to this.
yes,
Okay, now let's see whether indeed what you have here is equal to this. Because what you have in brackets here, okay, that simplifies into 2. Is that not it?
yes,
Okay, so it means what you have here is 2, and you get 2 to the power x. However, 2 to the power
yes,
x is not equal to 2 to the power 2x. Agreed.
yes.
Okay, so obviously you should know that this is wrong. So if you had the same answer, then you performed magic. That is not mathematics.
You had a different answer.
You had a different answer, yes. So now you know the right way to go. Is that clear? Anytime your x, something is multiplying, which is not 1, then it means you are supposed to use the power rule. But the power rule, the power of your 2 should be the x. So it's the x that should come inside, and the coefficient of what your x is supposed to come outside the bracket, just as we did over here.
Okay.
Okay, so now you know. You had, an original understanding. Now I have dispelled that. So going forward, clear that, delete that, and put this one there. Is that clear?
Yes,
Okay, good. All right. I like it when you ask questions. Let me know your problem. Unfortunately, I'm not God until you speak. I wouldn't be able to go into your head. Okay, so our last but one question, our last question together anyway. So what are we giving? I can choose not to write the giving, and I'll write 2 to the power, okay, 2x, okay, plus 1. So when you see plus, you know that this is the same as 2 to the power 2x, then times 2 to the power 1. Do you agree? Hello, do you agree?
Yes.
However, you can see that what you have here, we want 2 to the power x, but this is 2 to the power 2s. So we have to get its corresponding, okay, relation. So we know from where we just came from, we know this is the same as, okay, 2 to the power x all squared, then times 2, all correct?
Yes.
Okay, so it means I'm going to get what? 2 to the power s we know is k, then squared, then times 2. Okay, which will give us what? 2k squared. Am I right?
Yes.
Okay, so you draw your conclusion. Therefore, okay, your 2 to the power 2x, okay, plus 1, okay, is equal to 2k squared. So this is also in terms of k. Alpha. Hello. Are we all there?
Yes, please.
All right. Okay. So I'd wanted to give this one to you as a class where you do it, then we all mark together. But unfortunately, because of the interruptions, okay, I'm a little behind time. So we'll do this one together as well. Your assignment will have questions of this nature. So you convinced me, okay, with your understanding in that what assignment. So the last one that we are all going to look together, okay, or look at together, I should say, will be, okay, F. F, what are we giving? We are giving 2 to the power 2x minus 3. So whenever you see minus between the two terms, it means it will be 2 to the power, okay, your 2x all over, okay, 2 cubed. Do you agree? Hello, do you agree?
Yes,
Yes, please.
Okay,
please.
all right. If you don't agree, remember, don't hesitate to let me know, then I'll explain further. So this will be equal to, I know that I want 2 to the power x, not 2 to the power 2x. So I get the corresponding relation of this in terms of 2 to the power x. So that will give me 2 to the power x, okay, all squared. Then all over 2 cubed, we all know is 8. Is that clear? Okay, so in effect, we are going to get 2 to the power s, we are told is k. So we get k squared. Okay, all over what? 8. So you draw your conclusion. Therefore, okay, your 2 to the power 2x minus 3 is equal to what? K squared over 8. All correct?
Yes, please.
Okay, please, any questions at this point? Are we all fine? Is everyone fine?
Yes,
Yes,
please.
Okay, very good. All right, so if that's the case, then, okay, this brings us, okay, to the end of what we are supposed to do, okay, today. Okay, so we did the exponential equation leading to simultaneous equations. Okay, and now, okay, where you are given a relation and you are given another relation and you are asked to write it in, okay, in terms of one of the variables in the relation. Okay, so let me see. Someone has a message for me. Oh, you people. In fact, the other time, that's what I wanted to say. Oh. I wanted to say that those of you who have not seen me before, okay, that video is for you to see me. And indeed, you passed that comment. Anyway, that was just by the way. Okay. Anyway, thanks for the compliment. Okay, that's a gentleman's reply. Anyway, okay, so this is supposed to be it in terms of, okay, our meeting today. Okay, however, please take note what comes next. Okay, is your class assignments. Okay, so this will be the class assignment. You are doing this one right now. Okay, your class assignment. So let me quickly go back and, okay, at least you know that that's your class assignment. Sorry. So this will be, okay, today's lesson 3 class assignment. Take notes. So this brings us, okay, to the end of today's meeting. Thank you very much for making this lesson, okay, a wonderful one. Your contribution, your questions, and what have you so much were cherished. It's made the lesson a very good one. So God bless us all.